Welcome back. We're solving day 16 advent of code today. I've understood the problem. So basically you are given this grid and you start from the left, top left cell, and you have some direction of movement. So first you are going right, and for each of these characters, depending on which direction you come on this character, you will have a diverting movement from that. So all of the rules are mentioned here, and we just need to count how many unique cells will this tracing cover in the entire grid. We'll quickly start with implementation. Create a 16 input is this. For this is physics. Okay, input. Let me start the screen key. Okay, string line while we get a line. Great. Let's call it matrix mat dot pushback line, and we need this vector of string mat, and let's also initialize the rows and columns. Done. Now let's say we start some DFS function recursively from this position, and can I create an enum direction? Left, right, up, down, maybe. Perfect. And we start at 0 0, and the direction that we are currently at is direction of movement from this cell is right. Okay, void dfs, we are at ij and we have some direction, say dir. Okay, now I want to check which direction I'm going. Okay, first of all, let's check what is the direction. It's right. Should I use switch instead? Maybe. Is this the right syntax? It's fine, I can use this only. Need to do this for all of the 4 directions. Right, left, up, down. Okay. If we are going right and we encounter dot, then we keep moving in that direction. So this will mean, do we call this we traverse, we check whether this is a dot. In that case, we go to the right, which is I, j plus 1 with the same direction. Else, if it is there are so many cases, right? We have 4 types of symbols: forward slash, backward slash, a vertical line and a hyphen. Okay, dot is covered. We just need to check Matrify J is a vertical line, as if Matrify J is a hyphen, as if Matrify J is a forward slash and a backward slash is wrong. I think whenever we check backward slash, we need to do it like this. Now let's write the cases for this, and then we will convert them to all of these 4 directions respectively. So this wants to split it, so we are going from left to right. Okay, this will go up and down, so it would be I minus 1 j, and direction would be up means going from down to up, top, bottom to top, and we are going to I plus 1j, the direction down, right? And whenever we are going through this, this will be the same. So I go j plus 1 with the same direction. If we are going from left to right in this, we will go to I minus 1j, and direction would be up. And for this, it would go to the cell below it, and direction would be down. Okay, we just need to do this for all the cases. We are going left and we have a dot, that means we still need to go to the left, which is j minus 1. We are going from, wait, this was going left. Okay, it's going left, and okay, this is right. Now for this, it will be the same, because even if you come from left to right or right to left on this character, you will go, one ray will go above and one ray will go down, so this remains same. For this, it should go to the left now, so j minus 1. For this, it should be swapped with this, I guess, because coming from right, it should go down, and the cell would be on the row below it, and for this it should go up, row above it, direction up. Okay, fine, let's do this for the third. We're going up, so I minus 1, right? We're going up, and here it should be the same thing, because whenever we are going from down to up on this character, it will pass as it is. For this, it should be the left and right of it, so I j minus 1, direction left, and I j plus 1, direction right. For this, whenever we are going from down to, it will be on the same row but on the next column, and the direction will be right. For this, it will be on the same row but opposite direction with direction left. Okay. Going down, so I plus 1. Here also I plus 1. I guess these two should be same whenever we are going vertical direction. Okay, plus 1. Then going down means, yeah, for this character as well, whenever we're coming from up or bottom, we will be having these conditions. That is fine. Going down, so I j minus 1 and direction left, and I j plus 1 direction right. Let me just cross check this once. Dot right. Down. Okay. Okay, looks good. If we are outside the grid, if I is less than 0 or I is greater than equals to n, or j is less than 0 or j is greater than equals to m, return. Then let's visit the state. I wanted to know whether I can assign some values to these enums. And how do we get these value? Direct of nothing, dot. Let's cache this. It should be of array of int 3. Let's make it set. If cache.count I dir return, else we insert that. Right. And this will give us the count of all the values with directions as well. So I wanted to do one more thing. Let's say we have a vector of no, it's fine, we can just simply make it visited. What is the input size? Doesn't seem too large, so let's make it 500 by 500. and can visited of ij equals to true. Answer would be this. Let's run it. Okay, it works. Let's try on the large test case. Let's level test 7884. That's the right answer. Let's move on to part 2. Before that, I will take backup for this part. No comments or any refactoring required, so copy sol.cpp, sol part21.cpp. As you try to work out what might be wrong, the reindeer tugs on your shirt and leads you to a nearby control panel. There a collection of buttons lets you align the contraption so that the beam enters from any edge tile and heading away from that edge. You can choose either of two directions for the beam if it starts on a corner. For instance, if the beam starts in the bottom right corner, it can start heading either left or upwards. So the beam could start on any tile in the top row heading downward, any tile in the bottom row heading upward, any tile in the leftmost column heading right, or any tile in the rightmost column heading left. Okay, it can start from the border of the grid. You need to find the configuration that energizes as many tiles as possible. In the above example, this can be achieved by starting the beam in the fourth tile from the left in the tile from the left in the top row. Using this configuration, 51 tiles are energized. And in the above example, this can be achieved by starting the beam in the fourth tile from the left in the top row. This one, right? But what is the direction for that? From any edge tile, the reindeer talks on a so that the beam enters from any edge tile and heading away from that edge. Okay, in this case it went down because we, for the non four corners row, for four column cells, corner cells, we have two directions possible, but for these in between we move into the opposite direction. That's fine. And that will give us some visited cells, right? And okay, we need to try this for all of these corner as well as those. I will write C brute force only for this as well. So let me do one thing. Let me write a helper function which returns me the visited count from. So I give in the starting and the starting position and the direction. So it will give me the answer for that. So let's make it visited count. Now one more thing, I want to clear this cache and the visited array before performing this, and this should be from SISJ with this direction only. And before that I want to clear this visited array. Visited of ij is false and cache dot clear, right? Perform the operation, traverse the base from SISJ with given direction there. Right. Now I will do this for say the middle rows, right? Let's do it first for all of these and these, and then we will check for column in 1 to m minus 2, so that we only check for these. We will, let's say, get c1 as visited count from row 0 and this column, and the direction to go from here would be down. Direction down. And we can also start from n minus 1 row and go up, right? So from here we'll go above minus with the same column, but this should be up, and I just need to count the total thing, right? So answer would be max of these. This is for those columns, and then we will do it for row 1 to n minus 2. The same thing. First one was from this row and 0th column, and this was from this row and m minus 1 column. This should go to the right and this should go to the left. Now all the non-corner cells are left, so I can do that one by one, I guess. x of answer, comma, visited count from 0 0, and there are two possibilities, either down or right. This is top left corner, this is bottom right, so n minus 1, m minus 1. This can go up and left. 0 comma m minus 1 would be top right. It can go left or down, and we will have n minus 1 0 and n minus 1 0, which can go up and right. Let me check once again. This would be top left, top right, can go left and down, then bottom left, and go up and right. Okay, let's try this. $51 is the right answer. This is for the first part. Let's write on the large test case. This could be slow. This is fine for us. I mean, 10-20 seconds to get the answer is fine, but if there is some optimal approach, we can try it later maybe. That's it. It was a simulation type of problem. No, not much on the side of ideas and algorithms. Clean this. Okay. Git add. This is day 16, both parts. Git push. We are still left with part 2 for 14 and 10. I might do them later on some day. That's it for today. Thank you for watching.